Hi, welcome to Live Life Ravishingly. Today we are continuing our AI journey with Mr. Shivaram. Welcome, Shivaram, to my show.
Hello, Ravish. Glad to be here.
Thank you. So, today we are going to learn what is reinforcement learning, what is supervised learning, and unsupervised learning. So, come, let's start our journey with Shivaram on all these aspects. So, Shivaram, tell me to start with what is actually supervised learning.
Okay. So, when we are training AI model, we train by different methods.
Got it.
Okay. Supervised learning, as the name says, is when there is a supervisor or the data which has the information as to what is the input and what is the output. Normally, input is called X and output is called Y.
Yeah.
Okay. If X and Y both are available, it is supervised learning. That is, once the model, when you give the input, generates the output. Okay. What that output is for that single step of using the model is known. Okay. That is supervised learning. Okay. So let us take an example. I normally take an example of cats and dogs or apples and oranges. Okay. It's just for making the thing simpler. So let us take the example of apples and oranges. Imagine there is an image of an apple.
Okay.
And image of an orange. Okay. Now, when we show the model apple image, it has to automatically recognize and generate the output of apple.
Right.
For apple, let's say the code is 0. So when apple is shown, it should generate 0. And when orange is shown, it should generate 1. 1 is the code for orange. It has to generate 1. So we know that if image is shown, any image is shown, and if it has apple, 0 is generated. And when there's orange, 1 is generated. Okay. Now, how do you do this? How do you train the model for doing this? So first thing you do is to collect data.
Yeah.
So you go on internet, let's say, you download all the images of apples. Okay. And for all the images, now the image size of which you can pass into the model is of a fixed size. So what you do is you take all these images, you crop the images, you crop the images to that size. Okay. And then you say all the images which are apple, it should have 0 as the answer. And for all the images with orange, it has to have 1 as the answer.
Right.
Now, when you are training, you create this huge data set. Okay. Let's say there are 1,000 examples in that data set. Normally, you should have more, but let's say 1,000, right? In that 1,000, you keep probably 300 images outside. You don't want to use it during training because AI models are good at by-hearting. What if they by-heart the entire images?
Okay.
Okay. So that is called overfitting.
Overfitting, yeah.
So we don't want the models to overfit.
Overfit.
So to test whether they are overfitted or not, we need to do an exam, like the way we do exam for kids, right? In the education system. So we keep this few images outside our training set. Okay. So on the set of 700 images where we are using it for training, we have the images along with their answers, and we give that to the algorithm.
Okay.
What the algorithm does is it takes the image and it sees whether the 0 has been generated by the algorithm or not. Initially, the algorithm doesn't know anything, so it will mostly do randomly. Randomly, it says orange and apple, whatever, right? So whenever there is a mistake, there is a correction which is done during the training. So that correction happens automatically, and once it corrects, because it has done a mistake, it corrects. If it has done correctly, then reinforces. That means it makes the weight higher. The weights will be made lower or higher based on whether it is getting correctly or wrong. Okay. Now you do this process for the entire 700 images. When you learn all the 700 images once, it is called one epoch. Then you do it again and again and again. Multiple epochs you do. You learn the same thing, like doing multiple revisions. You revise again. So once you learn the content what is trained, you feel confident that it's working, then you use it on the test data.
Okay.
On the test data, when you see, if its performance is good, that is, if its accuracy is good, like let's say apples, it is telling most of the apples as apples. Most, like 90%, 95% of the apples it's saying as apples. 95% of the oranges saying oranges.
Okay.
And sometimes it does mistakes.
Yeah.
Okay. Then it is okay. You will feel okay. Mostly it is working, right? Then you use that model. Okay.
Yeah.
This is supervised learning.
Got it.
Because you have a person, the AI knows the exact answer beforehand, and hence it is easy for it to learn. When it does mistakes, it knows it has done a mistake, and then it is learning from that.
Got it.
So this is supervised learning.
Got it. Got a clear idea about supervised learning. Having said that, now what is unsupervised learning and where is it used?
Okay, so unsupervised learning is where you don't have the y part, only you have the x part. That is, you have apples and oranges. The images are there.
Okay.
Imagine you have million images. You don't know the right answer. You automatically want the AI to figure out what is the right answer by seeing the images by itself. Okay, so how do you do that? Here the accuracy will not be as high as supervised learning, where you have the right answers and so it knows how to figure out the features and all those things. Here you want it to somehow differentiate, separate them and create clusters of this information where the final answer is not there. So it's mostly used in clustering or segmentation, clustering and things like that, where the input what is given, okay, it sees the input and it has, let's say there are 1,000 things. It sees each one how far or close it is in relation with the others.
Got it.
And if something is close to this one, it brings them together and says these two are close to each other. And if something is far away from the other one, it separates them into different cluster.
Got it.
So bringing things closer to each other and further away from each other is clustering. So what happens is, you know that apple has this reddish and greenish tinge, yellowish tinge probably. And orange has orangish tinge and it can have a little bit of green, dark green tinge, right? So by using that information, if it automatically can figure out, it has to automatically figure out what is that which is common, what is that which is different. So we use something called as a distance metric, and the distance metric in this case can be color. It can be the shape, it can be size, but size is not a good thing to use in an image, because if the same thing is kept far away in an image, it looks smaller, but it's not smaller, it is far away, that's it. So you need to use the right kind of features to make the algorithm automatically figure out which is close by, which is far away.
Got it.
Okay, so imagine you have 1 million images of apples and oranges. You use clustering algorithm. It basically creates clusters, apples and oranges and all those things. Now that can be used and given to humans for labeling. First only you can suggest, okay, this is an apple, is it correct or not? They will say, yeah, it's correct, like that, right? Instead of them choosing, you can suggest, right? So clustering can be used as a precursor for other tasks, like unsupervised learning can be used as a precursor for supervised learning.
Got it.
To label the things and so on. It can be used for other things also. Okay, which are so if you know there are huge number of stars, how many of these stars have planets, you want to figure out. So you have all this data which is coming in. Okay, you can see where the anomalies are automatically and write some algorithm for that, and based on that you can cluster.
Got it.
Okay, stars which have anomalies, stars which don't have anomalies, and the stars which have anomalies, you find out where the planets are, whether they have planets or not, like that.
Got it. Okay, so we learned supervised learning, we learned unsupervised learning, we also got to know where exactly is used. So there's one more thing called as reinforcement learning, right? So what is reinforcement learning and where do you use that particular concept?
Okay, so reinforcement learning is used in many of these real life scenarios kind of things, where you exactly don't know what is the final, you don't know the output, you know only X, what are the inputs, and there's a goal you need to achieve. Like for example, two players are playing chess. Okay, now AI has to decide based on the current board position, that is the input, current board position, what should be the next move. Okay, but it knows whether the move is good or not only at the end, when the game is finished. At the end of the game, you know someone won or someone lost, right? And that is your reward, that is your final output,
right?
That is your why. Okay, so obviously you want the AI to win, right? But you don't know what is the whether you make a move, whether that move is good or not. Now, how do you decide this current move is good or not? Based on something which happens in the future, multiple steps into the future. Okay, So these are the problems where reinforcement learning is used, where we basically create an environment. This is now the chessboard is your environment, and the actors are AI is the actor which takes an action. The whatever action it is taking, it has a rule based on which it is taking that action. That is the policy.
Got it.
Okay. Now, based on some policy, you are taking an action, and that action is leading to your final win or loss.
Got it.
And when you win, whatever you get some points. If you lose some points. That is called reward. Okay. So now you create a setup like this, and you make the algorithm learn the right actions, which will lead to the success.
Got it.
So the way it is trained is you make the AI go through multiple different moves, multiple different paths, because now I can put a knight in front of a particular pawn and sacrifice that knight. But you may think, oh, this is a bad move because you lost so many points.
Correct.
But in next two moves, there may be checkmate.
Right.
You are winning.
Right.
So you need to basically have multiple paths, and in each path there is a higher chance of success, lower chance of success, and so on.
Got it.
Based on the sequence of moves. Right. So I'm just telling chess as an example. It can be for any games, any kind of board games, strategy games. It can be in real life also.
For example,
so you want to be successful in life. Now you can what you want to optimize is your total happiness. That is your reward.
Right. Absolutely.
Okay. Now to optimize your total reward, which is happiness, you need to take certain actions. Now you can have a policy which can be, I'll work on this. Okay. I will work on my health. I will work on my studies and all those things. Okay. And then I will go and achieve my success, right? Total happiness. I'll talk about a nice algorithm because you asked this.
Yeah.
Okay?
Got it. Yeah.
There's something called as epsilon greedy algorithm, which says that there are two ways of exploring the space. When you are put into a real world, you can do mistakes, you can do experiments. Like for example, entrepreneurship. In the beginning, it is tough. You lose
Absolutely.
that. Suddenly, you can have a huge growth.
Yeah.
Okay. So these kind of things, how do you figure out? Unless you do mistakes or exploration.
Correct.
Okay. So exploration is to go and find out what are the right things to do. Like, if I do this, what will happen? What if I do that, what will happen? Should I become a chef? Should I become a YouTuber? Should I become a AI programmer? Whatever, right? That is exploration, right? Exploitation is understanding that I'm good at this. Last time when I did this, I got this. So let me do this only. Okay. So maybe you have not explored enough.
Got it.
Okay.
Got it.
The epsilon greedy algorithm, what it does is, it has this parameter called epsilon. Okay. Epsilon tells how much exploration you have to do. In the starting, it is high, like 90%. So you are not learning anything. You are just exploring. Okay. Then the value of epsilon keeps reducing over time. You are exploring more things, but you are also figuring out in which path which you are explored, you are good. And you will take that path more often.
Got it. Okay.
You will not take the earlier explored paths. Okay. You will take the path where you are good at.
Right.
Okay. And slowly the epsilon is reduced to 0.1, 0.2, and it's kept there. It is kept there because environment keeps changing in the world. You should not make it zero. That means in the future you will not explore at all. You should be agile, but you should also know what is good at, and you should exploit that. Okay.
Got it.
So from this, what we learn, this is the real world learning from AI.
Correct.
Right. So what we learn from AI in this case is, there should be a healthy amount of exploration even when you become an expert.
Got it.
Okay. And in the beginning, that is in the beginning of your career, you should explore.
Got it. Fantastic.
This is the learning. See, AI can teach us life lessons.
Right. Okay, absolutely.
This is
fantastic. Yeah.
So reinforcement learning basically is a technique of using various algorithms to solve problems which are more of real world kind of thing, where the reward comes much later. You don't even know what is the input output pair. You know the current input, which is your current environment. When you take actions, every action you take changes the environment.
Got it.
Like every move you make in the chessboard changes the chessboard. So the other person, when they move in a different way.
Got it.
If you had taken a different path, they would have moved in a totally different way. The
Correct.
paths will decide the final output. So this is a very complex thing. The number of possibilities are huge. So training of RL is a very very powerful thing, and it is used in training large language models also. Yeah.
Thanks, Shivaram. Thanks a lot for sharing all your knowledge with our viewers and myself. We'll continue our journey. Stay tuned. Thanks,
Thank
Shivaram.
you. Thank you.